Okay. Now, sometimes you're going to be missing information, and you are going to have to find it while you're writing these equations of graphs. So one thing that you want to remember is the distance formula. I know we've talked about this a couple of times. We just did this when we did graphing parallelograms, but I just want to remind you of it again, just in case. So distance formula is the square root, parentheses, x2 minus x1 squared plus y2 minus y1 squared. That all stays in the square root. So remember, you subtract the x's, then square it, subtract the y's, then square it, then add those two together and square root the whole thing. So that'll give you the length. So that's going to be helpful if you need to find perhaps the length of the radius. That might be something you're going to have to find, is where the radius is existing and how long it is in order to write your equation. So for example, with a center at -2, 4. So -2, 4, this is the center. And there's another point on the circle. So the center is in the middle, but the point that the circle is passing through is a point on the edge of our circle, somewhere on the edge of our circle. So that point is existing at -6, 7, just right here. So if -2, 4 is our center, then this point connects and creates a radius. So basically I have I'm always so bad at sketching this out. It's so weird. Basically circle, and that point is on the circle. So first I need to use distance formula. Or I'm going to give you a little bonus lesson here. This is especially helpful if you're graphing it, or you can use Pythag. You know, like how in the world to find the radius. Well, I will show you. For those of you who didn't know this, the distance formula and Pythagorean theorem are basically the same thing. One is derived from the other. It's just done a little differently. If you really want to know how the two are related, ask me in class, and I will happily show you how you can go from one formula to the other. It's really interesting. Anyway, so if I look at this line I created, that's going to be my radius. I'm going to put an R here for radius and spot to show when I'm going to find it. So if we're doing Pythagorean theorem, we need to remember we need a right angle. So we need to create some perpendicular lines. So I am going to take my point that's on the circle and bring it down so that it's on the same level as the center point. And that's 1, 2, 3 steps. And then I'm going to connect that line on a horizontal with the center, and that is 1, 2, 3, 4 steps. So now I have created a right triangle to help me find my radius. So if you do Pythagorean theorem, this is 3 squared plus 4 squared equals radius squared, and my radius is going to be 5. Pythagorean triple. So if it's one of those that comes to mind, if there's sides 3 and 4, that hypotenuse has to be 5. You do not necessarily need to show me Pythag if you can just do that part in your head. I'm fine with that. So now we need to write our equation. So our HK, our center point, just a reminder that 4, and our R is 5. So our equation is going to say x minus -2, which is going to say x plus 2 squared plus y minus 4 squared equals, my radius is 5. Radius squared is going to give me 25. So 25. Now, sometimes you are not given a graph, or you might not find it as easy to graph it, so you need to use distance formula. So I have my center point, HK, right here. and I have some other point on the circle. And sometimes you might be given points that are too big to graph. So trying to graph it to do Pythagorean theorem might not work. So use the distance formula. So if I radius, I'm going to take my 2 points. So x2 minus a negative 13 squared plus y2 negative 16 minus a negative 15 squared. I'm going to go through and simplify. Negative 10 plus 13 is going to give 3. So 3 squared plus negative 16 plus 16 is going to give squared. So then 3 squared is 9. Squared is 9. My radius is 3. So now I have my radius. I have my center point. So I can write my equation. It's going to say, so x plus 13 squared plus y minus negative 6 squared equals radius squared, which is 9. And another example. Guys, repetition, I swear, is key. It's going to really help us out here. Now we have a circle with a diameter. So I don't have the radius. I don't even have a center point. How am I going to do this? Well, I have the diameter. We know the diameter goes through the center. And if I cut the diameter in half, that's going to give me my radius. So first I'm going to go ahead and do my distance formula to find the length of my diameter. So I have negative 4 minus a negative 4 plus negative 5 minus 1 squared. Those 4's are going to cancel each other out, and I'm going to be left with the square root of negative 6 squared, which is just going to turn into 6. So my radius is equal to 2. My radius is equal to the diameter, so my radius is equal to 3. And then I'm going to need to figure out, where do I find that center point if I'm given the diameter? Well, it's going to be at the midpoint. So remember, midpoint is x2 over 2 minus y2 over 2. This will help us. So I'm still going to use the 2 points that were given for our diameter. I'm going to plug them in here. Minus 4 over 2 and minus 5 over 2. And that's going to give me negative 4. So my center point is at negative 4, negative 2. Okay. So now I can write my equation. I'm going to say x plus r squared plus y plus 2, squared equals my radius, which was 3, squared, which is 9.